This was a set of plans back in the 1950s. It was a Speedy 14-foot International Dingy class sailor. I'm going to use Logic Trace 2018 to digitize all the frame parts from full-size plans. Because of the size of the sailboat, the 14 feet, I'm also going to use the jumbo board setup to digitize the diagrams. The biggest frame here was a 52-inch width, so it just fit the one digitizing board. I traced out all the frame parts and saved the files. Also remember here, the 2018 Logic Trace program has an edit command that if you make a mistake, you can go back and you can delete that portion and redraw it. The frames have drainage holes located at the bottom, so we're going to use the circle command to draw out these holes. The circle command echoes back and gives you the diameter of the circle and allows you to input a change if required. It's very simply done. You just touch 3 points. This is the boat transom, and it'll be cut out of 3/4 inch plywood. Also, a quick note here, I always save my work frequently. In case I make a mistake, I can go back to that saved portion. The specs on the boat, it's a 14-foot boat, and the beam is 5 feet. The weight's about 165 pounds finished. I imagine that would be a bit extra when you start adding fiberglass to all the joints. Also talks about the seating capacity. For racing, it's 2 adults, and for cruising, it's 3 adults. So there is room for a lot of people. Here I'm showing the text command. I find that very interesting because you can label all your DXF files. The documentation actually states that all the holes that are in the frames are to lighten the weight of the boat, but I feel it's for drainage. I'm saving my work here, and I'm also going to add a label to the frame again. These are the 2 combing plates which form the top of the bow. Documentation also talks about a thrilling speed of 15 miles per hour. And we'll also outsail boats twice as large. They're saying all these facts because of the hull design. I never gave the boat size much of a thought until I assembled the frame parts, and then I was quite surprised of the width of the boat. The beam ties 2 combing plates together on the bow. Once I finish tracing all the frame parts, then I'll put all these DXF files. I'm going to run them through Aspire 10.5, check the vector quality, and do some nesting and create toolpath. Because of the nesting here, I was able to use a 1.5 sheets of 3/4 ply. Also, because of the nesting, I was able to use all the scrap pieces for extra support, the knees. I also inserted extra support in the bow to support the bottom of the keel and to give me something to screw the 1/4 inch plywood to the sides. Now that we have our tool paths, we're ready to start the CNC cut. I set up the CNC with a 1/4-inch carbide end mill. I was running around 19,000 RPM at about 70 inches per minute feed rate. Mind you, cutting 1/4-inch plywood's kind of like cutting butter. This shows cutting one of the knee supports. These bow pieces connect to the stem. To demonstrate the cutting, I didn't use a dust collector hood. I just used the hose connected up to the vacuum system. So that's why some of the videos are a bit jerky, because I'm trying to hold the hose, trying to take a few pictures. You can also see here we've programmed fillets around each one of those cuts where the stringers join on. Fillets give you a little bit of slop there, so when you put the stringers in, they're not tight. The nesting turned out good. It utilized the whole 4x8 sheet, and what was left over was extra. All the parts were programmed with tabs, so that part wouldn't come free as it's being cut, and I also used some nails to keep the sheet down. The beauty of utilizing one sheet and the nesting is you don't have to remove your material off the CNC table until the cutting is all done. This shows the combing plates being cut out. All the parts are removed, the tabs are sanded, we're ready to go. I inspected each frame and applied the crosspiece for support on the table. A special support table was built out of 2x4s and sawhorses to support the boat during assembly. This table also helps to align each frame where it's supposed to be. Once the frames were all glued up and the chines glued, I was able to flip the boat over on its backside. Because of that 4-inch keel plate, it was easy to support the boat. Here's a good shot of the chines. The stem here shown will have a piece added onto the front and carved. That'll give the boat a good nose. In fact, I had just put a piece of 3/4 ply at a bit of an angle just to show that the boat does have a nose. You can see it here. So this will conclude video number 1. And here I've shown the assembly of the frames, all the stringers, the chines, and getting ready for the sheeting of the bottom and the sides.